Hello guys, my name is Melbay Guy and today we'll be continuing our programming class. So in the previous session or in all the previous sessions, we've been learning about what programming is and how to put things together to do this or do that, do that. In today's session, we are going to practice, we are going to do some exercises, you get it? So we are going to, you know, put everything we've learned so far together and make something meaningful. We want to put them together and come up with something meaningful. So today is a bit practical. We are gonna, you know, solve some exercises. We are gonna practice more so that we can understand what we've been doing so far and the idea of programming. Then we can continue with the other ones, the rest of the sessions. So I've written some exercises here. It's over here. Exercise. Write a mini application, program, or software that takes two numbers and subtracts them. Write a mini application, program, or software that takes two numbers and multiplies them, and divides them and sums them. So there's one question. We need to tackle that one. After then we'll do the second one, then we'll do this third one, then we'll do this fourth one for this session. So now let us understand this. What is programming? We already said that programming is basically a communication between you, the programmer, and the computer. And in the communication, the programmer teaches the computer how to perform certain operations, or the programmer teaches the computer how to assist people in solving their problems. And we also said that the end result of programming, if someone is programming, what's the end result? What's the output of it? The end result of programming is a software. And it is this software, it is the software that will help users or help people solve their problem, or it is a software that users will be interacting with to solve their problems. So anytime you are programming, you should know that the end result of the programming is a software. You are trying to build an application, you are trying to build a software, and that software will help people to solve their problems. So that is what basically that's what programming is all about. So we understood that computers have done from session one of some last week or week one session. We understood about computers. Here we said a computer cannot do anything on its own. It relies on instructions to perform. We've done this. You've been through this, you know. So we've learned that computers are dumb and can't do anything on their own. So for a computer to be able to assist us in our daily task, we have to teach it how to do it, how it should help. You get it? And it takes a programmer to teach the computer how it should help people. So the end result of teaching the computer or programming is a software. It is a software that will help people to solve their problems. So that's what we're discussing here. So we have a problem here. We said we should write an application, program or software that takes two numbers and subtract them. So first of all, we can think of it this way. So we have some people, they are faced with the problem of subtracting two numbers. They can subtract two numbers, but they want the computer to help them to subtract it because maybe the numbers are too large. You get it? The numbers are too large, so they need a calculator or they need to do it faster. Maybe they have a short period to do it. You get it? So they want to subtract two numbers. That's a problem. They have some numbers they want to subtract. They have two numbers they want to subtract. And that is the problem. And they need assistance from the computer, but the computer doesn't know how to subtract numbers. Yet the computer doesn't know how to subtract numbers. But if we teach the computer how to subtract numbers, it can do it faster than human beings, or it can do it faster for the people. So the people are stuck with, subtracting two numbers, multiplying two numbers, dividing two numbers, or summing some two numbers they have. Yeah, some two large numbers. And they need assistance from the computer, but the computer can't assist because the computer doesn't know how to sum numbers, doesn't know how to divide numbers, doesn't know how to multiply, doesn't know how to subtract. So we, the programmers, must teach the computer how to do this, how to subtract numbers, how to multiply, how to divide, how to sum. We need to teach the computer how to assist in solving the problem, help the people in solving the problem. So we do that, we programmers do that by creating a program or a software or an application. And that application will help the people to subtract their numbers. So first, we're going to teach the computer how to subtract numbers. So we are going to program, we are going to build a software, and that software will teach the computer how it will go about subtracting numbers and or helping the people solving their problem. So first, we've learned about what do we need first. Okay, now we know that the people will be entering their numbers. We have to take the numbers from the people who want to perform the subtraction operation. Okay, so we need to be able to take their values, then we will let the computer perform the operation for them. So how do we take the input from the users? How do we take the users' value? We first need to declare a variable to hold the input that we take from the user. So we declare a variable A, we declare another variable B to hold the inputs that the user will be entering. So var A, var B. And we'll use the prompt statement. We'll use the prompt statement to take the inputs. So the prompt statement will let the computer ask them to enter something. So we use the prompt statements. And inside the prompt statement, we'll pass in an information to guide the user on what he or she is supposed to type. So we are going to say that, please, okay, enter first number. And whatever the user is going to type, we want to store it. So we want to store it inside the variable A. So this is how we go about it. So we say, so let me read that up. So we want to store this guy. So whatever we take from the user, we want to store it inside the memory A. Now we will be taking two input from the user because the user is going to enter two numbers. So we need two instructions. First instruction is going to let the computer take the first number, and the second instruction is going to make the computer take the second number. So, and when we leave it this way, the first time the computer will take the number and store it inside A, and the second time, this statement, the computer will take the second number and will store it inside A again. So the initial number or the previous contents of A or the value inside A will be erased because now we are putting something else inside A. That's why we need a second variable called B, so that the content inside this memory won't be erased. So we are going to take input, put it here, we take input again, and we are going to put it inside the B. So now we've been able to take two input from users. So we've written a program that can take two input from users and store it in the computer memory or variables. So write a mini application program or software that takes two numbers. So here, this is where we solve that problem. So now it's taking the two numbers here. And I already said that to take numbers, to take input from user, you need to declare variables. You need to create a memory space to hold them. You can't just take values, input from users. You need somewhere to store it. That's why we brought in variables. So now we've taken the two numbers, and there's another instruction. It must subtract them. So the program, the software must be able to take two numbers and subtract them. So we need an extra variable here. We need a third variable here. Let's see. The third variable is not mandatory, but I prefer to use it. I prefer to use it. Get it? It's not mandatory. But it makes it, like I said, variables of memory helps us to reduce our code, simplify our code. Should I do it this way? Any way that you want to do it. I just want it to be readable, so let's make it this way. Okay. So now we've collected three memory from the computer. The first memory is named A, the second memory is named B, the third memory is named C. And we've taken first input. We are going to take one input from a user and store it in A, another input from a user and store it B. Now, the third thing we're going to do is we're going to process the inputs. So most times now, basic applications, what they do is they take input from users and they process it. You get it? how do we process the input? How do we want to process it in this situation? So what we want to do is we want to write an expression A minus B. What did we say about expressions? We said that expressions are statements. Are statements that are usually evaluated and produces a result. You get it? So expressions are evaluated by the computer. So there's an expression. When we give it to the computer will evaluate it. You get it? So the computer will evaluate this or calculate this or solve this and give us a result and give the programmers, will give the results back to us. So when we send this instruction to the computer, this will instruction to the computer will ask a user to enter something and the computer will store it inside the memory. When we send this instruction to the computer will evaluate this expression. Get it? So inside A, there's a value inside A, which was entered by the user. Inside B, there's a value entered by the user. And we brought this guy, the subtraction sign. Inside here, we know that as part of a program, we have operators, arithmetic operators, addition, subtraction, division, times, which we can use to perform operations on variables. So we have our variable A, we have variable B, and we are performing operations on them. So in other words, we can say that we are processing the inputs that we took. We took data and stored it in A, we took another data and stored it in variable B, and now we are processing it. How are we processing it? We are subtracting them. So after subtracting them, what do I want to do now? I want to store the result of this expression, of this operation inside the variable or the memory C. I've already declared C, so let's say C. So what is happening here? We are performing operation on the variables, variable A and B. We are subtracting the values, and we are storing the answer or the results of A minus B inside the value C. We are storing the results of this inside the value C. So now we are done. That's all for the program. So the next thing we have to do is we have to show the results to the user. You get it? We need to show the results to the user because after performing the operation, processing it, and we don't give the user feedback or display the results to the user, then what's the point of the program? There's no point of the software because the user gave you two numbers to perform operation on it for me to subtract. After subtracting, you don't want to display my results to me. So what the hell? So how do we display the results to the user? We've already learned about the statement called alert, and we use alert to display information to the user. So when we write alert and we put the name of the memory that we want to display the content, we can put A here, we can put B here. When we put A here, the content, whatever the user entered in A will be displayed. When we put B here, whatever the user entered inside B will be displayed. When we put C here, C contains the results of A minus B. You get it? So this time, the content of C, which is the result, will be displayed, and we are done. So this is what we call a program. So this is the end, and this is the solution for the section 1. What's this question? So this question, the question here, write a mini application, program or software that takes two numbers and subtract them. This is a program. You get it? This is the program. And I told you a program is made up of series of instructions or a set of instructions. So we have a statement here, 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 and we have a statement. So how many statements do we have here? We have 1, 2, 3, 4, 5, 6, 7. So we have 7 different statements being joined together to help us solve our problem or achieve our goal. So this program, when we pass it to the computer, it will teach the computer how to take two numbers and subtract them. You get it? And I told you the end result of programming is what? A software. When we send this program to the computer, it will create a mini software that will allow users to be able to enter two numbers. And after the users enter the two numbers, it will subtract it for them and give them their results. So let's see. Let's copy the word program and I copied where I just selected all of them and I press Control C. Be careful before you delete everything. So Control C. Now I'm going to paste it here. So I could have done it here, but it was going to be tedious. It was going to be tedious writing it here. So sometimes we pick a text editor. You know, there's a text editor. I know about it, a notepad. So we can pick a text editor to edit our program. Then we just bring it here so that we can pass it to the computer. Get it? So we have our program here. We want to send it to the computer so that the computer will carry out the instruction. This is a program. When we send it to the computer, it will create a mini application, a mini software, or a mini program or something. And this software will help people to do what? Enter two numbers, and the computer will subtract it for them. You get it? So in a way, we've taught the computer how to take two numbers and subtract it by writing this instruction. You get it? So how should the computer behave or help in solving the problem? We determined it. We instructed the computer. It's up to us because we told the computer, ask the user to enter something, ask the user to enter another, ask the user to enter a number, a first number, ask the user to enter a second number. Now we have the number. So I want you to subtract this number from this number. And now I want you to subtract these numbers. After subtracting these numbers, I want you to store the result inside the variable C. And I want you to display the content in the variable C to the users. So you see, it's just instructions. And the computer will follow this. And after the computer follows this, you realize that the computer is now assisting us. So watch, let's run it. Boom. So now we've got our mini application here asking us to enter a first number. So we're going to enter 4. It's asking us to enter a second number. We're going to enter 3. Let's see what we get. We had 1. So 4 minus 3 is 1. And this is the program. You get it? So this is the program that teaches the computer how to take two numbers. So you see, when programming, we said here that computers are dumb. They can't do anything. Over here, computers cannot do anything on their own. It relies on instructions to perform operations. Yeah, before we had nothing to use to, we had nothing to use to enter our number to, perform subtraction. We didn't have that. So we had programmers to teach computers how to do that. And now we have something like that. So now we have something that we can, boom, write our first number, second number, and to show us the result. Now we have something. How did the programmers do it? They did it by writing the program. The program contains a set of instructions, that will teach the computer how to do it. So the computer has no idea that, oh, I have to create memory spaces and I have to take input from a user, one input from a user, another input from a user, and I have to subtract them and I have to display the result. The computer has no idea like that. So we taught the computer that. So first we instructed the computer that, okay, I want you to give me a memory. I want you to reserve a memory called A. I want you to reserve another memory called B. I want you to reserve another memory called C. So when the computer sees this instruction, the computer will reserve a memory code A and will reserve a memory code B after seeing this instruction. So it will reserve another memory code C. So here the computer will reserve 3 memory for us. You get it? Then here we are telling the computer that now you can ask a user to enter something. So tell the user to enter first number. So the computer will do that. The computer will ask the user, enter first number. When the user enters the first number, we've instructed a computer that if the user enters a number, store the result inside A, store it in the memory A. And here we are instructing the computer that if the user enters second number, store the result inside the memory B. So now we've been able to take the user's input, the user's first number, we stored it in A. We've been able to take the second number and we stored it in B. So we've taken the input from user. Now we have to process it. So we have to teach the computer how to process it. What should the computer do with the input that has taken or the values that are in the memory at the moment? So we told the computer that, okay, we want you to evaluate this. We want you to perform this task. We want you to do a subtraction of the value inside the memory A and the value inside the memory B. So we pass this expression. This one is an expression. The computer, like I said, expressions are statements or instructions that the computer evaluates and gives us a result. So expressions can be evaluated and to produce a result. And before we said about expressions that the results that we get from an expression can be the result that the user is interested in, can be what the user is interested in, or can be used for further processing. So here, what's the result of A minus B? The result is being stored in C. And we just printed the content of C, whatever is inside C. And you could see that whatever is inside C is what the user is interested in. You get it? So if I run this program, I'm entering 4 inside the memory A. I'm entering 5 inside the memory B. What is this? The negative one is here, is the result that has been stored inside C. So I was displaying it with this command. The negative one is interest. The user is interested in the negative one. Oh, okay. So the answer is negative one. Oh, so if I have a 4 minus 5, the answer is negative one. Okay. So the user is interested in this result. You get it? So that's why we say that expressions are evaluated to produce one result, and the result may be interested, or maybe what the user is interested in. It may be the reason why the user is using your software or your application. You get it? So that's an expression. So we write an expression, and we could directly, we don't need, we don't need another memory to store the result of the expression before we can display it. We can display it directly. We could say that. So computer, please display A minus B. We can do it this way. This one two ways. We can write this statement. But to make things simple, we try to store the result inside C, and just instead of writing A minus B inside this to make it more horrible, we just write the C, because now we are displaying the content inside C. You get it? So that is it. And basically, that's how programming works. You get it? So it starts small like this, and it goes, it graduates, it graduates, it graduates. So we have, and you see this program, what does it do? It helps us to, solve the problem of subtracting two numbers. If the number is too large, like what is 15,263 minus 1003. What is that number minus this? When press OK, the computer is giving it to us with 14,260. Fast, it just came. Imagine you were doing it by yourself. How are you going to add it? It's going to take some time for you to do the calculation. But the computer did it faster for us. Now the computer itself has to solve the problem of subtracting two numbers. Before, the computer couldn't assist us. The computer didn't know how to do it. We, the programmers, told the computer what to do. We told it to, okay, declare, put some memory, give us memory as a user to enter something and subtract this from this and display the result to this. That's how we taught the computer. And now the computer has learned, and now the computer can do it. So we can give it any value now. We can give the computer any value now, and it can now perform it for us. 29 minus 3 is gonna be 26, or that 26 are the correct, you get it. So now we have an application. So we that's it for the exercise 1. Let's go to the exercise 2. What is the exercise 2? The exercise 2 is saying write a mini application or program or software that takes two numbers and multiplies them. So it's more like this one. It's more like this one. So it's going to take two numbers, but this time the operation we are going to perform on the variables, we're not going to subtract them. We are going to multiply them. That's number 2. That's number 2, multiply with them. So we can still declare our variable A, variable B, variable C, and we can still ask the user to enter the first number, we store it in A, enter the second number, we store it in B. The only difference here, the only changes we make here is the operation we perform on the variables. So if we perform a subtraction operation on the variables, the software will be doing subtractions. If we change it and we make it, okay, times, asterisk is the symbol for multiplication in programming most times. So if we make it A times B, so this time when we take the input, first we put and store it in A, and take the second input and store it in B. Here we are multiplying A and B, and we are storing the result in C, and we are displaying the result. So let's run this program and see what will happen. So I've pasted it inside here. You have to paste Control V, or you just paste it inside here. Then let's run it and see. So this time it's still asking us to enter first number. We want to enter 3. It's asking us to enter second number. We're going to enter 2. Let's see what we'll get. We had 6. Why did we get 6? Because 2 times 3 is 6. Or 3 times 2 is 6. I've forgotten what we wrote. So one was holding 3. A was holding 3. I've forgotten. Let me try to kill this time. Be careful. So okay, 3. So we are storing 3 inside A. And we are storing 2 inside B. Okay, so now there where. So we had 6 because we collected the first input, which was 3. We stored it in A. We collected the second input, 2, and we stored it in B. And here we are multiplying them. We are multiplying the results. So this is an expression. And when we give this expression to the computer, it will multiply or perform operation on these variables. It will multiply the contents of these variables. And this whole statement here, the equal to the assignment operator, is saying that after the computer performs this operation, it has to store the result inside the value C, the variable C, the memory C. So when the computer stores it here, then we'll tell the computer to display whatever you've put inside C. So at the moment, 6 is inside C. We can even type C to check what is inside C. You see, we can see that 6 is inside C. You see, 6 is inside C. So that's it for the second one. So we didn't do anything unique in the second one. The second question is more like the first one. You could see the second question. It's used almost the same thing as the first one because we need variables, we need memory, so we declare them, and we need to take inputs and store them. So we left it that way. And we need to display the results, so we left it that way. But the only thing that changed was the expression. So this time we multiplied the contents, not we didn't subtract it. So the third question is we need to divide them. We need to divide them. So from this guy, arithmetic operators, we have addition, subtraction, we have multiplication, and we have this division. So what do we do? It's simple. You can also do it. You just have to change the operation. Get it? So we have data inside A, we have a number inside A, we have a number inside B, and we want to divide them. If we put a minus here, it means we want to subtract them. If we put a times here, we need asterisk, we want to multiply them. If we put a division, we want to multiply the input that we took. So here we want to divide the input that we took. So when after division, the result will be stored inside C, and we'll print C to the users. So let's see. Let's go here. Let me clear the screen. And we need to paste it here. We can just right click and do paste. So there's a program. There's a simple program. And this program, when it is being passed to the computer, it will create a mini application that will allow people to be able to enter their will be able to enter 2 numbers, and it will divide it for them. So enter first number 5, enter second number 3. What is 5 divided by 3? 1.66666. So if you have a calculator, you can check it. You realize that 5 divided by 3 is this. You get it? For me to get the application again, always I have to send the program to the computer like that. If I send a program to a computer like that, then to run, because after we end, so the first time the computer, the computer will reserve space, reserve space, reserve space. And now the computer is here. It is performing this instruction. So it is asking us to enter first number. You can see it here. So when we enter 6, now it has moved to the second instruction, the fifth instruction. It's asking us enter second number. You can see it here. So let's enter 8. So now it's performed the operation here, A divided by B. After performing it, it's stored it inside here. This one, it won't show it to us over here. It happens internally. So it's performed the operation, store the result here. And then this command that is saying that pop up the result inside the C. Pop up the memory, the contents of the C. And that's why we had a pop-up. And the C is holding the results of the operation. That's why we have it here. So you see, it's cool and it's fun. It's simple. And let's do the last one. The last one is sum. So the reason why I've placed sum below is it's something. I don't know how to say it, but watch here. The plus, there's the symbol, the operator plus is used for performing additions, 1 plus 1. for performing addition. But this operator also has a name called concatenation in programming. That's a name, concatenation. If I can spell it, concatenation, something like that. So another name for this is called concatenation. The plus sign can be used to add text together. So I can have A here. I can have text A, letter A, and say plus letter B. And look at what we got. A plus B, we had AB. So let's say Tim. Okay, let's say Melbay plus Guy. What do we get? Melbay Guy. You get it? So that's the issue with plus. So when you're dealing with plus, we don't just say this plus this like that. Otherwise, it's going to give you a horrible result. So let's see something. So this is our program. And if we want to find the sum or we want to do addition, or we know that we have to just change this guy to plus. Let's change it to plus and see what will happen. So 2 plus 3. We had 23. Why is 2 plus 3 23? Why is Tim plus why is Melbay plus Guy Melbay Guy? Why is A plus B AB? Because this guy, let me show you something. This prompts, you know, this guy, the one taking the input, it is called a text input. This one is called a text input field. So it is used to take text. Get it? So it is used to take text, and you know, text are numbers, letters, variable, characters, symbols, everything. These are what we call text. Hello, hello is text. A is text. Even 9, if you write 9 inside this, 9 is treated as text. You get it? So if we have two texts, like A and we have another text like A, if you have two texts like A, yeah, we have two texts like A plus another text like B, the result is what? AB. If you have a text, a number which is a text, like we have let's say we have a 2 and we have another text plus another text 3, the result is what? 23. You get it? So watch this. 2 is inside the double, it's inside the quotes. 3 is inside the quotes, a single quote, meaning it is text. It's not treated as number. The computer doesn't see it as a number, although we know it is a number. The computer is seeing it as text. You're seeing it just like A, B, C, D. You get it? So, but if I write 2 plus 3, this time 2 is not inside any quotes, 3 is not inside any quotes. So the computer knows that this is a number, this is a number. That's why it gave us 5. But if 2 is inside the quotes and this one is like quotes, then it will give us 23. You get it? So that's how it works, because plus is for concatenation. It is used to join 2 or more text. You get it? But in case of numbers, it is used to perform arithmetic operation. It is used to add those numbers. So anytime we use the prompt to take the inputs, sorry. Anytime we use the prompt to take the input is taken as text. Watch, I'm going to write 6 and watch. You see 6 came, 6 is inside the quotes, meaning 6 is treated as text. It's not treated as number. So if I say 6, this input plus another input, A plus B, so 6 plus 6, it will give me 66. So how do we solve this problem? In other programming languages, we don't do that. We don't solve the problem that way. In other programming languages, you just say 2 plus 3 to work. But in this language that I'm using, this is how we solve it. We have something called a statement called pass int. Pass int. So this pass int, this guy, inside here, we put the name of the memory we want to convert to int. So let's say we have a value being entered inside. There was a prompt and we have a value being entered inside A. We entered maybe 5. Because we use a prompt, the 5 will be treated as a letter. So then when we add them, instead of it to give us an actual value, it will just join them to concatenate them. So what we have to do is we need to put the variable, the name of the variable inside this pass int. And this statement will tell the computer that, hey, this guy, the content inside the memory A or the variable A is a number. Treat it as a number. If the computer is able to treat it as a number, then to give us the right result. So we just have to come here. We just have to come here and replace this guy. Replace this guy like parse int. Parse int. And let's put the A inside. So we have our addition here. We have our parse. So in other languages, we don't do parse int. There's nothing like parse int. But you see, we have different languages and they all have a way we represent things. So for it to work here, we need to use extra information like parse int A and parse int B rather than just A plus B. If I do A plus B, it will treat the number inside A as text and the number inside B as text. But if I do parse int A and parse int B, it will treat the contents of A as a number and it will treat whatever is inside B as a number. You get it? So now let's see whether it works. So now let's go and paste it here with the passing. So this time it's still the A plus B, but this time no extra information telling the computer that whatever is inside A is a number, or whatever inside B should be treated as a number. So now let's run it and see. So we're going to enter 4 and we are going to enter 5. We know the result should be 9. You see, we had 9. Great. Let's try it again. Let's enter 5 and the second number 5. And let's see, we'll get a 10. Now, let us remove the pass ins from there and see what we're going to get. We are going to enter 5 and 5 again. So, so with the pass ins, we're able to get the actual values. So this time we're going to remove the pass in from there and leave it just like A and B, A plus B. So when we do it that way, watch, we're going to enter 5 and we are going to enter maybe 6 and we are going to get a result of 56 because it joined the text, it joined the content inside here together with the content inside here because this thing is called concatenation. It is used to join text. But if we use the pass ends, here we are telling the computer that treat whatever is inside the A as a number and treat whatever is inside the B as a number. That way, when we write 5 and we write 6, we'll get 11 instead of 56. So that is it for this session. Now we've actually solved this guy. So the solution for section 1, let's see. Question 1, what's the solution? So let's do solution. Let's send it a bit to the center. To the center here. Solution. The solution for question 1. So the solution for question 1 is question 2. So solution for question 1, in question 1 we are doing subtraction. So the operation here should be, you can just leave the pass int there so that you don't have to worry again. But with subtractions and other ones, we don't need pass ints. The computer is able to tell that, oh, it is a number. But when you use the addition, the plus sign, that you need to specify pass int. So there's it for question 1. The solution for question 2. The solution for question 2, we are looking at multiplication. So like I said, we don't need pass ints if we are not using the addition. The computer will be able to tell that it's a number if you're not using the addition and we are using the other operators. But if we use the addition there, we have to be able to specify that it's a number. So solution 2, we did multiplication, Lord have mercy. And solution 3, we did about division. And so this solution. Okay, this 3. So 3, we did the division here. In solution 4, we did the addition. Like I said, addition has so much problems. So we put the past into there to solve our issue of 1 plus 1 is equal to 11. So we need a passing to solve that issue. If the pass int will give the computer will make the computer aware that it is a number. So 1 plus 1 shouldn't be 11, it should be 2. So that's it. So this is solution for the first question, a program that subtracts or a software that subtracts numbers, it's simple like that. So you realize that everything is the same. The only thing that changes is the expression. So expressions are very important because they help us to write lots of programs. It's the expression that processes our data for us. You get it? So there's this part that we'll be taking inputs and we'll be using expressions to, process those inputs, and we'll be displaying the result. So this type of method is for simple applications. So thanks for joining this class, and I appreciate. So in the next session, we would do more exercises. So to end this week session, so in the next session, it will end with 2 sessions. So we'll do more exercises. So let me find some exercises we can do in the next session, then we end for the week.